Hello everyone, good morning. Hope you are doing good. So let's get started.
This meeting is being recorded.
Let me share my screen. I hope my screen is visible to you guys. Okay, so I know last class, so I was not sharing screen. So you guys were not able to see like what we discussed in last 10 minutes. So don't worry about it. So we are just gonna do a quick recap of yesterday's class about the regular expression, and then we'll move on to the new topic. Okay, cool. So let's do a quick recap of what we learned yesterday, right? So we learned about regular expression and we called regex. So where it is used to, let's say if you have a very heavy text field or something you want to search in your document. So if you are looking for certain patterns that you can easily find using regular expression. So now how it is different than simply doing a control F. So for example, if you want to find a phone number, you may need not to know exact number of your phone, but you just need to know the pattern. The pattern is that anywhere 10 numbers appearing at the same time, that is something which you want to extract. So these kind of patterns, you have to think what you want to identify, and you can create a pattern out of it and get those things from the text. Okay, so that's where the regular expressions are very much useful. And let me tell you, it is very much useful in industry, uh, whenever we have to do such kind of things, right? Automatic text extraction. So let's say from the bill, from the invoice. So we are right now, so this is the current problem I'm telling, current actual project on which I'm working, where we have to extract the text from the invoices, different kind of bills from different vendors. You get this invoices, right? So that is our actual task. And there, so regular expression is one part of it, but that is again, it's very heavily used apart from other advanced ML algorithms or machine vision task which I'm doing. Apart from that, regular expression is also one of the important area where we have used and leverage this information. So that's why it is very much useful even in practical scenario. Okay, so how does it work? So there are different meta characters. Like for example, we learned, right? So this backslash is where you can use wherever, let's say some of the symbols have a special meaning in Python, right? So you saw parenthesis, close small parenthesis, or a question mark. All these have a different meaning, special meaning in Python. But when you want to avoid a use case of that meaning, when you want to literally find a question mark in your text, right, that time you can put this symbol, so it will drop the special meaning of a character following it. Okay, then we learned the square brackets. So it represent a character class. So whatever you will put inside, it will literally search for that particular letters or symbols. Or you can give a range also, like a hyphen p or p hyphen q, so which means that it will search any letter which is coming between a to p. Okay, then you have this caret string. Basically this tells you that whatever you give after this word, your sentence should start with that. Similarly, dollar, it should end with that. Then you have simple dot, which means that it is any character except a new line, right? So if you have put this one dot, so which means that it can match any character or symbol or white space, right? It can be anything. Similarly, you have a pipe character, which means that or, so you either this or that. Then you have a question mark, which tell you whether it is a 0 or a 1. Okay, only it will appear, ya to it will appear or it will only once. Okay, so that's what the question mark denotes. Then you have this asterisk symbol or multiplier symbol. This denotes it can be any number of occurrences including 0. Then you have plus, which means that one or more occurrences. Then you have curly braces. Within that, you can define exact number of occurrences which you should be there. And then you have this close small parenthesis to enclose a group. Okay. So as we saw, right, what this backlash does, simply you can use the backlash if you literally want to search a dot. So if you want to search a dot, if you do here, it won't give you. Okay, without using this. But if you give, it will tell you that it has matched. So as you see here in the first output where you have not given backlash, it has not matched. It is just telling you the first letter. It has just matched G, because special meaning of this is any letter it will search. So it has found G at the first and it has given you that. But if you literally want to search for this period symbol, you have to put a backlash, and that's what you can see. It is found between 5 to 6. So this one it has found. Okay. Similarly, this is square brackets. You can give a range. 0 to 3 will be 0 to 3, 1 to 3. A to C will be ABC. And if you put this kind of a symbol, which means that now its meaning changed, which means that it will search except 0, 1, 2, 3. So it will ignore these letter and it will search any other thing apart from this. Okay. Similarly, A to C, it will not select ABC, rather it will search anything else. Okay, this caret dot, all these things we have already discussed, right? Then you have these special symbols, right? So then slash B means it matches if the word begin or end with the character, right? With a given character. Then you have D, that is for digit 0 to 9. Capital D is a non-digit character, right? That is equivalent to this class. Then you have small s, that is white space. Then you have W, which is means that any alphanumeric character, it can be A to Z, capital A to Z, 0 to 9, including uh, underscore. So any special symbol, it will not be accounted for. Okay, so if you have any special symbol, this symbol will not search for that. It will search only for these classes. Okay, cool. So let's look at few of the examples, right? How we find it. So as you can see here, we have this string, and let's say if I want to find digits, I could have simply given a pattern called digit, and I could have given plus symbol, which means that if it is one or more, so if it is one or more, what I will find, if I'll do find all, I will be able to get this number and this number both. Okay. Then you can use compile method. We already saw wherever you have very heavy or complex strings. Now that's time compile method is really used, as you can give your string in multiple lines as well. So you just create an object with your pattern string and simply do a find all or a search within that. So in this, it will give you all the letters it have found. So you here you found anything between A to E. So it will find everything which is between A to E. Okay. Of course, it is a case sensitive, so it is a small, right? So that's why it did not select it capitally. It started with E, then A, then B, right? Then there was D, and then B, like that. So capital letters it won't push. If you want to include capital letter, you have to mention capital A hyphen capital E as well. Okay, so this is a very good link. I have already shared this link in PPT. So here you can see understanding also, they have clearly mentioned why you have got this output. So this tutorial, it's very good. Even if you are not able to follow few of the things as of now, one thing you can ask me right away, or if not, then go through it. You already have the clarification over here. So whatever examples you are seeing here, you see the output and then you see the clarification also. So it is very good in that sense. Okay, cool. So likewise, you can find any word, whatever you want to find out, right? You can give the asterisk symbol like this, that what it will search is, it will search for A, B and any letter after that. So if you do find all, it has find the first pattern, that is A, B, right? Then it has find A, B, B over here, right? Then it has found A, right? And then it has found A, B, B. So you can see understanding here, they have clearly explained. So our AB slash, which means that A accompanied by any number of B's is what we are looking for. So this pattern is what? A and B can occur anytime, right? So what is the first pattern? First is AB. So B can occur anytime, right? So first is AB. Then you have ABB, right? ABB. Then you have A also, because B can occur 0 also, right? If it would have been plus, then this one will not come. But since it is multiplier, so I mean this asterisk symbol, so we know it is 0 or more, so A is also occurred. Then you have A, B, B, B. So these four patterns it has found. Okay. So likewise, along with find all and search, you have something called split also. So what this does is, simply as the name suggests, it will split your string from the pattern. So it splits string, by the occurrence of a character of a pattern. Upon finding that pattern, remaining characters from the string are returned as a part of resulting list. So for example, let's see over here. What we will be seeing over here is, uh, I have given a pattern how I want to split, and then I have given my string. So this is my string. So how do I want to split it? Any word, right, wherever there is a first occurrence, I want to split. So likewise, you can see it has splitted this first one, it has splitted all words separately. Okay. Similarly, here it has splitted word also, then s also separately, then likewise it has splitted. Correct. In here also it has splitted on 12th Jan 2016, wherever there is, because it does not include space now. So wherever it sees a space or any other symbol, it just splitted over there. Cool. So here you can see now it has splitted based on digits. So based on digits, which means that on it has split because just now it saws 12th, right? So now then it has split it Jan. This one has made one symbol. Then 2016 it has split it, right? Then it has seen at. Then it has removed again digit. It has found this colon. So that's where it has split it. And then again AM. So wherever it splits now, it doesn't count that. Okay, clear? Then you learned sub method also. This sub is for replacement. So there you can give first the pattern, then you can give what you want to replace with, and then you can give your string. Okay. So as you can see here, we want to replace ub with this symbol in this string. And here you can pass a flag called ignore case, which means that whether it is a capital UB or a small ub, it will be replaced. So if you see the output, what you can see is this ub it found first, so it has replaced with this symbol. Then again it found ub over here, it has replaced here. Okay. If you don't give you ignore case, then it will not split over here, it will not replace over here. Okay. Cool. Then you have sub n, which is similar to sub only. It does that in a way of providing the output. It is different. It returns a tuple with a count of total of replacement and the new string rather than the string. So it just return a string along with this count that how many times it has replaced. That is the only difference. So it is up to you if you want to use sub or sub n. Okay, then you had already know search method. We have seen that it just searches the first occurrence and it shows you the first occurrence, and if it is a find all, it will give you all the detail, or wherever it has match, it will give you all those places. Okay. Then you have what match also. Okay, so this is all search, right? Yeah, I think that's it. So there is another function called match as well. So the difference between search and match is, search, it will, okay, let me show you with an example, I think. So search is something, right? It will ignore whatever it see afterwards. So it is like trying to just search whether this thing is there or not. However, match is, it will exactly match, right? And if it is a perfect match, then only it will give, otherwise it won't. So you can think of like match is a subset of research. So in search you will get more results, in match you will get very less results wherever it is a exact match. And we will see with the difference, where is the difference. I think it should be there in here. Mhm. Okay, so let me show you with the same example, right? So here what we are doing is we have imported, so this is our regular expression. We want to search wherever A to Z letters are appearing. That is one group, and another group is digit. And where both the places we have plus, which means that one or more occurrences. Okay, and this is my this is my string where I want to search. Okay, so let's see what happens if I just do that, right? So it is giving me let's not look into this all these things. Let me show you directly in notebook what output I will get out of this. So I will see match, and it has matched. Okay, so it has matched where June 24, because that's where you were having letters followed by number. So this is what it has found. Okay, so the match is June 24. Okay, so let's see how it will be different in match. Okay, so in match, if I mm, okay, let me show you directly over here. If I do match, let me do match one. Okay, and here I will do match. I think it's gonna give you the same. Okay, it doesn't. So here you see match did not give you the same thing, because it didn't give you any output. I just ran it, right? It did not give me output. Why? Because there are all these things also. So you see now it has given output. So the difference between search and match is it searches in the entire string, and wherever it found the pattern it just give you. So it searches the entire string. However, for match it has to be a perfect match. So as I was telling you, right, my string is that there is a only just one single word, and then there has to be a digit. However, here I had all these words also before, and that's the reason why it was not searching. So if I give an entire string, it was not searching. You see, it was not giving me any results. But as soon as I removed all other words, because in my pattern I have mentioned that there has to be only one word only, correct? And that's the reason it has, not matching when I gave multiple words. Now if I have single word, it is match. So that's the difference between search and match. Match, it will try to find the exact thing and then only it gives. However, search is like it doesn't care if you have anything before or after the pattern. However, in match it cares. It checks what you have before and what you have after. If it is exactly matching, then only it will match. So let's say using match function, if I wanted to do the same thing, I have to mention that instead of just word and this, I think I have to add space also in this, because I have spaces over here, right? So I think I have to add spaces also. I think now it should work. See, now it has worked, but now it has found the entire sentence, because that's what it is, right? I have given that there can be letter also, there can be spaces also, at least one, and it can be multiple. So that's what it is saying. If there can be letter, there can be word, there can be letter, there can be word, and then at the end there is a digit. I hope the difference between search and match is clear. Typically, most of the time we use search only, right? But as I said, right, if you are very particular that this is only you want and there is nothing else exist at the top, at the before and after the pattern, then you should go for match. Clear? Any doubts between search and match? PPTs, I will request the ExcelR team again to upload it. What I was told is they have already uploaded all the things. I have already shared all these materials with them, and they have uploaded in GLMS. So if it is not, I will tell them today again to upload it. Okay. But any confusion in search and match, or any any other regular expression function? No? Cool. So let's get going. Then I think we have already covered all the regular expression thing. Now it's done from my side, right? Okay. So then let's move on to the new topic, that is NumPy, right? So far we have learned, right? What are the basic different things in the Python in bits and pieces. Okay. Now we are going to start, uh, you know, with a, you know, what we are now going to pick one library today, and we are going to see how, what all things are there in that library, how to use that function. Okay, so NumPy is such one library. So in this entire series we will be mainly focusing on two libraries, NumPy and Pandas. Reason is very simple: 90% of the time these are the two library which are used for any kind of data modeling you do, data pre-processing you do. This is what is used very much heavily, and that's the reason we are learning, these two library in much detail. We will be learning each and everything. So whatever we have learned so far now, what is data frame, arrays, how do I, read it, index it and all. So now we are going to learn that in more detail. Okay, so this is gonna be really important library, so please pay attention and make sure that you understand each and everything. So most of the thing I will already tell you as we are going through, right, what function is more important as compared to others. So pay attention where whatever I'm saying is most important ones, right? Because see, when somebody develop this library, there can be 100 function. So of course I'm not asking you to pay attention for all 100 focus all 100 functions equally, but as I said, I will be walking you through all the functions because you should be aware of it. Just that whenever something is very important, I will especially highlight that, so pay extra attention to those functions. Okay, cool. So with that, let's start this new library, NumPy. So we have been importing this already a lot. So import NumPy, and typically NumPy is a big, so I aliases it is NP. So import NumPy as NP. So likewise I have done. So it has various functions and things within that. So let's see one by one, right? So NumPy is a general purpose array processing package. It provides a high performance and multi-dimensional array object and tools for working within arrays. So what is array? I already told you when we covered the data types, right? So it's nothing but a homogeneous kind of a data frame where you can have multiple rows and multiple columns. The difference between array and data frame is array has to be a homogeneous. All the columns or all the values in the in arrays has to be of same type. Maybe everything character, maybe everything numeric, maybe everything integer, maybe everything float. Okay, so there cannot be anything like we have in data frame, right, where one column, like we were seeing salary data. So one column was person's name, then another column was his salary, third column was number of experience, right? So one column we have character, other two columns we have numeric. So I will be calling that as a data frame, not array. So pay attention. What if somebody asks you what is the difference between array and data frame, you should be able to tell that. Okay. uh, so array is a NumPy table of element, usually numbers, all of the same type, indexed by tuple of positive integer. In NumPy, number of dimensions of the array is called rank of the array. Okay, a tuple of integers giving the size of array along each dimension is known as shape of the array, right? And array class NumPy as ND array. Okay, um, elements in NumPy arrays are accessed by using square brackets and can be initialized by using nested Python list. So let's see. Let's try to create an array first, and then see. Then I will explain you each and everything. Okay, how to create an array? Simply, you can create it like this. So simply I have called this library, right? So now in this NP, there is already a function called array. So np.array, in that you can provide a list, and that's it. So your array is created. Okay, so what are the different properties of this array? You can simply press dot operator and tab. You can see all these things are available within this array. So let's say if I want to know shape of the array, so there is something called shape as well in this, right? So shape, if I do this, so there is a three, the size of the array is 3 comma, which means that there are three values in it. Okay, because that's what you see here, right? So if you want, you can print this array and you can see that's how it is look like. How you can access it also. So if you see array 0, you will see it's 1. If it is 1, then you will see it is 2. So it's, since we know that the shape of this array is only 3, so if you press 3, it will give you out of index error because it started with 0, so it is only and 2. Okay, so that's how you access the arrays. Uh, okay, you can create so this was one dimensional array, right? Why one dimensional? Because as you can see here, there is in dimension, because shape is what? Dimension only, right? What is the dimension of this array? What is the shape of this array? So you just see one value. So let's say if I want to create two dimension array, I will simply have to put two brackets in this, right? And then this is one list, then another list could be 4, 5, 6. You see like that. So if I see now, the shape of the array is 2 cross 3. So there are 2 rows and 3 columns, right? Let's see if I can give even bigger than this, but this time let me give this 6 comma 7. Let's see if this takes it or not. It created it, but then it understood that it is a list. So you see, that's the difference. Earlier it was giving you like a array, but here it gave warning that nd array was ragged nested sequence, okay, is deprecated. If you meant to do this, then it has been created. So what it is saying, it is actually not an array. So if I see the type, right, still it might show me the array only. So it is an array only, but actually the inside these things are not array anymore. It has become the list. So what I meant to say, if I do this, you see now it has changed, right? So now if I see what is the array, this is an array, right? Right, so this is an array. However, previously if I put it like this, and now if I do, it is a list. So that is the difference. So this entire thing is array, but within this array, the first element is no longer an array as soon as you gave the different shape, because that's what we learned, right? List can have multiple length of items, but array and data frame cannot. So just be careful whenever you are creating, right? It doesn't, if it is not giving any error, it doesn't mean that it is correct, right? So this is actually partially correct. If you really want to create an array, it has to be of similar length. Okay, so that's the array. Okay, so likewise you can create of multiple shapes and all, right? So it is 3 cross 3 arrays. Okay, so likewise you can see array with rank 1 as in order 1 or shape 1. This is with 2. Okay, so so this one you can do. Now you can access the array using index. Okay, so let's look at this example, right? So I have created such a big array. Right, let's say now if I want to index it, what it will do. Okay, so first of all, let's check what is the shape of this array. Air dot shape. So this 4 cross 4. Okay, so because there are 4 rows and 4 columns. So now here what I'm saying is I want to access. So this column means I'm giving a range, and if I don't give anything, by default it takes it's 0, right? So I am saying that I am taking from 0 to, even though it is written 2, but this will not be included, right? I have already told you it start with 0. So it will just only put 0 and 1. So 0 and 1 is this, right? These two rows, 0 and 1 row, correct? And then in columns, in columns it is just taking second one, 0 to 6. So whenever you press 2, iska matlab you just need these second row column only. But let's say if you just press only one, if you do this, it has taken actually uh, from these two. So let me show you what I meant. So if I do this, I have, what I'm saying is, initial first two rows 0 and 1, and initial first three columns 0, 1, 2. So 0, 1, 2 I have printed. However, if I want only third column, then you have to give two columns. Then which means that only third column I want. So likewise, you can do indexing of the array. Clear? Because it starts with 0. So row wise and column wise, everywhere it will start with 0, 0, 1, 2, 3. And this one, likewise, you can index. Okay? Cool. Then you can perform basic operations like let's say if you have this array A and B, you can add one element to everything. So if you do a plus 1, it will by default it will perform element wise operation. So in each element it will add 1 1, right? Similarly, if you subtract, it will subtract in from the each element. Okay, so it does this automatically element wise, right? And if you do a dot sum, this will also be done, right? So for example, here if I do r minus 5, so you see everything, each and every element has been subtracted by minus 5. And if I do r dot sum, it's a function, that's why you have to put parentheses. So see, you might be wondering, how do I know when I have to give parentheses or not? So let's say I ran sum, right? It says that it's a function. So we know that whenever you want to call a function, you have to give parentheses, right? That's how you define that I am calling that function. So you call that function and then it will give you value. So this value is nothing but you just simply add all these things and you will have your answer, right? So you add all the elements and that's what the array sum. Okay, so all these things are already there as a part of array. You can add two elements, so it will just do again element wise. So it has to be have the same shape of the a and b if you really want to perform it better, right? So then that's how you can add. Then you have data types in NumPy. So every NumPy array is a table of element, right? So as I was telling you, right, we just now we saw if you give different elements in each table of elements, it will still create an array, but then those will be list. Those inside item will not be an array because those are of different length, right? So all of the same type indexed by tuple of the positive integer. Okay. So then how you can construct a data type object. So in NumPy, data type of array need not to be defined unless a specific data type is required. NumPy tries to guess the data type of array which are not predefined in the constructor definition. So what does it mean? So if you create an array over here and if you check the D type, so that's how we can check. Now, one way is you can check type of this variable, or then you can check the data type also of this. So if you do the data type of this, it will be telling you whatever is there data inside now, what is the type of this. So for this, if you do x dot d type, which means that it is integer. Okay, integer 64. So for these kind of thing, it will tell you it is float, right? So this is float. And so what it is trying to say is either you can specifically uh, specify what is the data type. So like in here we have specifically said that d type is equal to np int 64. So let's say by default, even if point 0 is written or something, now it will force that its data type is integer, not float or any other thing. So likewise, you can predefine your data type in num whenever you are creating an array. Okay, fine. Then you have math operations, right? So math operations are like sum you can do, transpose you can do. So as in here you can see we have already defined that this is float. So even though we have given integer number, if you print this array, you want to print, it will be 4.0 or something like that. So if I print this now, r1, you see already point is coming because I have defined them as a float. If I would have defined as int, it won't come. You see that dot is gone. So that's how you can predefine what kind of data type is there. Okay, so you have already defined two arrays. Now you can add those arrays. So either you could have done arr1 plus 2, or you can use np.add and it will sum those two arrays. Okay, then np.sum is summing all the elements within the array that you can do. In fact, you can do a square root also. So it will do a square root of all the elements in the array. So whatever operations you give here, na, it performs element wise by default. So for example, if you want to do the np square root of here, right? Uh, as you can see, it has done a square root. 4 का square root 2 होता है, 7 का 2.64, 2 का 1.414, 6 का this. So it has already done element wise square root operation. Then you have transpose also. You can do transpose r1 dot p. So it has transposed. So now earlier it was 4726. Now it has been 4276. So these two are transposed. So transposed, I hope you understand. So you can exchange your rows with columns, right? So that's how you can do the transpose. Any questions? Any questions so far in NumPy operations? No? Okay, fine. So these are the list of all the operations which you can perform. So either you can check here, or I have already told you one function. What is that? dir. You can do np. So all these things which is there, will show you what all you can do within NumPy. So let's quickly have a look what all things we can do over here, right? So there is all function, any function, take, put, arrange, v dot, random, these things we can do, right? So one by one, let's see what all is important. We will go through them and try to perform those operations. Okay. Okay. So let's try to create first n dimensional array. So array in NumPy table, right? So we call it as n dimensional array. Why n dimensional? Right? Basically, how many dimension they are. So simply here you can see there are two rows in that, right? So it is two dimensional array. It has two axes. Okay. So first dimension we call that is length, and second dimension has length of 3. Okay, so it has two dimensional. First dimension has 2 because there are two rows, and second dimension is 3. Okay, it has 3 length, correct? So it overall shape can be 2 comma 3 for this case. Okay, so this is a two dimensional array. Let's try to see if we have three dimensional array over here. Okay, so so here we have, so there we are telling you there are many multiple ways to create array. One way is simply we can create an array from the list. So here we were having multiple lists, right? So you can stack your list and just put this within the bracket of np array, your array will be created. Okay. So that is one way. Another way is from tuple also you can create, like simply this is your tuple, right? 132. Likewise, you can create your array. So if you create your array using tuple, so that's how it is done, right? So it will automatically convert this tuple into a list, because as you can see, right, this has converted into a not exactly a list, but I mean it's an array only. because if I do B0, it will be just, this kind of thing only. So it has already converted tuple into an array, right? Then you can actually do create a repetition also. So so for example, if you want to create a blank array with just 0 is in this, so you can do that by simply giving, let's say, a equal to np dot zeros. So there is this something called np dot zeros, and you can give the shape of this. So let's say 4 comma 5 you want to give. So you can see here it has already created this array. So you have 4 rows and 5 columns. Okay. Similarly, you can create with all ones also. So np dot ones. You see. So with ones, it will have all the elements as one. So most of the time we have to create these dummy arrays. So where of certain shape we want, so you just give the certain shape, and whether it is a 0 or 1, you can create. So that is one way. Now other way could be just create a constant value array of complex types. So this is for complex, so you can ignore. There is no point of because we don't use it, so that's fine. You can ignore it. Okay, then array indexing. So we have already seen how we can slice it, right? How we can slice the array. So as you can see here, this example, we have seen that it will give you initial 2 rows and third column, because it start with 0 index, right? So initial 2 rows and third column of 2 rows. Okay. Similarly here, it in this array, you can do the slicing like this also. So what does it mean? Let's see. So let's say I have created this array and I am doing the slicing like this. Integer array indexing example. So what does it mean? That I am actually getting 4, that is 0 element. Then I am getting 6. Then I am getting again 0 row and third column. Okay, so that's how I'm getting. So if you see, you can actually give integer if you really want to get some random values in between, right? If you don't want to give an entire range, that you can do by simply giving them rows and index value. Correct. So let's say you want so what does mean? This is the row value and this is the column value. So your first element is from 0 row and third column. So 0 row is this and third column is this. So that's why you are seeing 4 over here. Similarly here it is first row, that is this row, and second column. Right, so second column is this, that is 6. So that's why you are seeing 6 here. Similarly here, third row is this, and first column, that is 0. So that's why you see 0 over here. And similarly again, this is fourth row. So that is last row and first element, that is 3. So likewise, between this row and column, you can put it over here, and that's how you can get it. So one way is you give the entire range like this. But let's say if you want something in between with the index value, that also you can get it like that. Okay. So integer array indexing example. Right. And you can of course do something like this, that give a condition, right? So let's say you want to print values wherever it is greater than 0. So you can simply create a condition and pass that condition into an array. So for example, you gave a condition, let's say cc equal to arr wherever it is greater than 0. Let's see what this cc value will be. So what is the cc? Actually it is a true and false metric of the same size. So wherever this condition is true, wherever it is greater than 0, that is true. If it is less than, that is false. So first element is false, right? So it is like that. You can simply pass this within the index, right? And that's it. You will be getting the values. So wherever you have true, those values only you will get. You won't get false. Clear? So that is also one way to do. So basically filtering out, right? So you create a condition, you filter out like this. Okay. Any questions so far? Okay, good, fine. Then what we have, just give me 1 minute. I'm just taking 1 minute water break. I'll be back in 1 minute. Okay. Yeah. Okay. So now let's move further. So there are some more basic operations also, like plus. So I hope I'm visible. My screen is visible and I'm audible. Just a quick check. Okay, perfect. Yep. So as you can see here, we have arrays, and then we can perform these operations. So I already told, right? It will be by default element wise. So you can add anything, you can subtract anything, you can multiply, and you can do even a square also. So if you do double multiplier, that means that you are putting a power of it. Okay. So all these operations also can be doable over here. Okay, then you can get something like max and min also, we call unary operators. So many unary operations can be provided, like sum, min, max. So we already saw sum. You can in fact get max and min also. So if you do air dot max, if you do like this, you will get the maximum value out of it. So whatever is the maximum value, that is 8, you will get. But let's say if you want to get uh, column wise or row wise, right, maximum values, then you can pass access. So what is this access means? So if it is row wise, then you give 0. If it is column wise, then you give 1. So if I give 0, you see I got a entire list. So that is row wise maximum value. So if I show you the air list, so whatever is the maximum value row wise, so this is my first row, right? Maximum value is 4. So that's why you're seeing 4 here. Maximum value is uh, sorry, this is maximum value is 6. uh, why it is giving column wise? Just a second, let me show you. Okay, wait. I think I so row wise. Oh, sorry. Uh, my bad. So row wise is x is equal to 1, and column wise is x is equal to 0. So why I got confused is in pandas library there is a different way. So it's just opposite of it. So you have to be careful and check once that what does it mean, because tomorrow I'll be taking you through pandas, and there if you see x is equal to 0 is row wise operation, and x is equal to 1 is column wise operations. But uh, I don't have an answer why they did not make it uniform across. Maybe because there are different persons who develop NumPy and pandas library. So pay attention, whatever is there, right? You first check yourself, if that is what you want, then only you perform it. So as you can see clearly, it is written, it is a row wise element when x is equal to 1. So that's what you are seeing here. If you are performing row x is equal to 1, that is row wise operation. So in first row it is 1. then in second row it is 6, then in third row it is 8, then in fourth row it's 4. So that's what you are seeing here, right? Similarly, you can perform min operation. It will give you min value row wise. So minimum value here, minimum value here, minimum value here is -7. That's what you are getting. Okay. And same thing if you do 0, that is column wise. So it will be seeing vertically. So vertically again it is 4. Vertically here it is 2. Vertically here it is 7. Then vertically again it's 8. Similarly, min also you can do. So just pay attention if you want row wise and column wise. So what is the value you should be passing in Excel? Okay, cool. Then sum if you do, it will give you sum, and in fact you it can do sum you also access wise. So if you do sum, so it can perform row wise and column wise sum operation also. Okay. So sum, if you see, this is column wise, so it has added all these value and that's what it is giving you 8.6. Similarly here it is giving you this. Then you have cumulated sum also along each rows, that also you can do. Sorry. Then you have binary operators, so like plus, minus, division, right? Multiplication also you can do. Okay, so matrix multiplication also can be done. Then you have universal function like sin, square root, exponential. So all these things also you can be, it can be done, performed on this array. Okay. Then talking about data type, so you can check what is the data type by simply doing AR D type. So it will tell you what is the data type of all these objects, right? So this means it gives you information about type of the data, whether it is integer, float, or some other objects, right? Size of the data, right? Then you have something called sub array also. It will tell you what are all the data types about it, right? So simply you can say np dot d type of whatever you want to, your metrics or some whatever it is, you can do that. There is something called byte order also, but it's not used much, so that's why I'm just simply ignoring it. So it's not used for, at least for our use case. Okay, then let's go to the array creation, right? So we can create, so we saw how we can create array, right? We can create it using list. We can create from simply dummy arrays we can create with 0 and 1 element. Okay. uh, or we can create even, by simply a list. So a list is also an array actually, if you think like that, right? So if you are giving this particular list, right, you can simply give it an np.array and that will be converted into a array from a list. Okay. Then you can actually import array also, array creation using a array function. So one is you have NumPy, and from within NumPy you can create arrays. But apart from that also there is another library called array. From there also you can create an array function, right? So how to do it? Simply array you can call, and you can initialize array with the values and with the signed integer. So by simply doing this, as you can see here, what we have done. Okay, let me simply copy paste this. So I'm just importing array. It has just simply created an array from this. Okay. Array using NumPy method. NumPy is geek.empty. So all these operation exist, but it's not much of the use. So that's why I don't want to confuse you guys, and that's the reason let's avoid them. Okay. Um, what all things are important, we will be just learning those methods, right? So here we can avoid. Then we have already seen indexing nothing but slicing, right? So we have seen that you can convert a array, you can create like this, you can do the indexing also. Okay, and then mm, so already we have seen these kind of indexing, right? So basically, if this is the array you have got, so you can already call with this row and column operations, right? So if this is a 2D array, so simply you can give 0, that is your first row, and then column between 3 to 5. So 0, 1, 2, 3 to 5. So these 3 to element, third and fourth you will get, right? So you are getting this thing. Uh, Right, so that's what you can do. So this is the answer, right? 3 and 4 you are getting. Simply these operations you already know, right? So I am simply avoiding it. Mm, So so it has shown highlighted. So all these things are in detail, it's mentioned. So if you want, you can go through it. But I think I have already given you so many examples. So all these things should be clear by now. Indexing and slicing. So let's see what are the main operations we can perform, right? So again, this is basic slicing. Uh, we are not going into that. Right. So then you have data type objects. Okay. Yeah. So now let's see some actual use case of this. Okay. Another way of creating an array could be, this as well. So what you can do is, right. So there is something called arrange function. So what it does, simply as you can see here, one way I told you, you can create a dummy arrays using 0 or 1. Other way could be you can simply, actually it's np only. Then let's say what this arrange does is it have all these values between 0 to 1. It's nothing but range operation only, right? It will give you all the values between 0 to 1. Now what you can do is you can reshape these values. So how can I reshape? Basically, you have a 12 elements, right? So you can reshape as you want. So let's say I want to reshape it to you know uh, array where I have 3 rows and 4 columns. So basically your multiplication should come to 12, correct? Because you have 12 element. So let's say if I want to reshape something like that, you will see I got this array. It's nothing but how to get the quick dummy arrays, that's all. So you can create a list, whatever numbers you want, and randomly it will generate those numbers and create an array. So that's how you got an array, right? So let's say I got this array, then what operations I can perform? I can simply go over it, right? So iterating over an array, what does it mean? Let's see. So this geek is nothing but NP. So they've called NumPy as geek. So what they can do is, I have not actually saved it. So let me save it. So this is an array. Now in this, simply I can go one by one on this. So what does it do? NP dot ditra. It's basically iteration on each and every element. So it's a iterator, right? So again, I mean, it's up to you how you want to go it. You could have gone from rows to columns, right? So what is the use case? Why do I need it? So let's say you created an array. Okay, now you want to put a loop on that, row wise and column wise. You want to perform some operations one by one. So you have to put a loop, right? You have to first put a loop row wise, then you have to put a loop on the column wise, right? Like if I have to tell you, you have to give like, if I don't know this iterated operation, right? How will I go about it? If I say I have to go over all the elements of this numpy, how will I do it? The simple reason, I mean, the simple way how I know is I will put a for loop for I into range of, because I know there are 3 rows. Okay, so I will put a range of this, right? Actually, for I in range. So let me see, what do I print? Print, right? Print I. So you see 0, 1, 2, it is printing, right? So how will I print it? I will go first row wise, and then within row wise I will go to column wise. Okay, so column wise I will go 4j in range of, columns kitne hai yahan par, 0, 1, 2, 3, right? I mean, actually there are 4 columns, right? So I will give 4. Okay, and within that how will I go about it? A, then I want to go first in I, and then I want to go in J, correct? That's how I will print. So if I see, I let me print this. You see, I have got the similar answer, the same answer. So this 2 or 3 line of code I have simplified by just doing this np.nditr. This is what that function do. So whenever you have to perform certain operations, right, on each and every element, then you can do that. Okay, if it is a easier operation, like if you want to add something or you want to multiply, delete something, you don't have to do it. You could have simply do a plus 1, a plus 2. But not day to day operations are so easy. You may have to, let's say, आपको हर एक एलिमेंट पे अलग अलग चीजें परफॉर्म करनी है. So you can put a condition. If it is first row, then you do this. If it is second row, then you do this. If it is a third row, then you do that. So likewise, then there is no other way. You have to put a what do you say? These kind of for loops or iterator. Okay, clear? Why do we need that np.itr function? Basically to loop over the entire values of a NumPy array. Okay, cool. Then what do we have? Again, simply I've created this dummy array. Okay, and you can see that I can do even a transpose also. Okay, and then we can iterate in a given order. So we can actually iterate in a given order also. So what this order see? So controlling iteration order. So there are items when it is important to visit the element of an array in a specific order, right? So irrespective of the layout, element in the memory. So the default having the behavior described above is order K to keep the existing order. It can be overridden by C or F for the Fortin order. So let's say if I give this order equal to C, let me see what difference it makes. So here if you see, it is just going one by one, like it is going first row, then second row, then third row, like likewise it is going. So if I give certain order, let's say if I give this order, okay, I don't see any changes. It still seems to be same. Let's say there was another variable called f. Yeah, now an order has changed, right? So now I see it is column wise. It is first going one column 048, then it is going 159, then it is going 2610. So all these are different arguments you can give if you want to change the order. So let's say if you want to go column wise, default is that only, row wise. And if it is column wise, then you can give order F, and that's how it will be done. Okay, fine. Then what you have? Modifying array values. So you can modify those values and give a flag. So as I was telling you, right, what is the need of going through it? So let's say if I want to modify something, right, so I can do that by passing the flag that I want to read and write the elements, and then in here I can make a change whatever I want to. Okay, so that I have done. Then what else is there? Order C, external loop, multi-index. So all these operations, I think it's not that important. So that's why I'm skipping them. So the main important function I already told you, this NDTIR. which is for iterating over an array, right? Then let's see what we have in binary operations. So binary operations also we don't perform much. So let's skip that as well. Let's come to the mathematical and string operations. Okay, mathematical operations is we perform most of the time, right? So what you can do is, let's say I have created an array and here it is a another array of sign values. Okay, so like, yeah, like likewise you can do, right? So for here what we are saying, I have created an array, right? So that's nothing but a list over here. So this is how the input array is, and you can simply pass it in a any of the mathematical function. Let's say I want to take a sign function of this, so I can say simply np.sign and pass that array in that. So if you see, it will be giving you me the same array with the sign function, right? So sine of 0 is 0, then sine of this is something this, sine of this is this. So likewise it is giving me the sine function of all these values. Okay, similarly you can give cos also. So all these functions can be performed. So these mathematical functions are available within NumPy. So all these functions you can perform based on your need. So as I was saying, right, all these things exist, but at least in my entire career, I have not used ARC cos, ARC tan, degrees, and all these functions. So these are very rare, which is used. But it is like, see, as I told you previously also, right? My job is not teaching you all 100 functions available. My job is how to find those operations. So now I have already given you this link. I already have told you how to go through it, how to read it. So if you are able to read it at your own and understand what each and every function is doing, that's all. My job is done. So that is what the whole point is. तो आपको बस वही सीखना है कि how do I read it, how do I test it in notebook, and how do, if I have to use it, how can I use that? That's all. Okay, but at least in my career I have not used this function, so that's the reason I'm simply passing it over. And rather than spending time over here, I would like to spend in some other valuable places, wherever it gives more value to you guys, right? Okay. Then what do you have here? It's round. So round is, yes, round is what is used. So round, if you see simply, it will be telling you that rounding off, how much round off you want to do. Okay. So let's say if I have a list over here, right? And so let's say this is my list. Okay. And simply if I do np dot round, you see round. And if I give an array, let's see, it has by default rounded off, because by default the argument is 0, so that it has to round off only for 0. So that's why you see it has just rounded off. 1.5 को 2 कर दिया, 2.5 को 2 रहने दिया, right? 3.5 को 4 कर दिया है. Likewise it has rounded off. Okay, but it is up to us. We can give more value also. So the argument here is I'm just looking for place argument. uh, yeah, so the decimals is the argument, right? So you can give how much decimal you want. So decimals, let's say you want 2. So 0 will not be there, right? So that's why you are seeing the same thing. It won't add, I mean, it doesn't matter, right? If you write 1.5 or 1.5000, but let's say if you have a big number, it will round off to 2 places. So it has rounded off to 2 places. Okay. So likewise you can round it off. np.round you can use. That is one important function. So then again, floor, CL, all these functions exist like math function. No? So all these functions are also available in NumPy. So one more thing. So हर चीज को करने के दो तरीके होते हैं, right? That's why you will feel there are some function which is repetitive. There are some function which is there in math or library also, like floor, seal, and there are some function in NumPy also. So it is completely fine. Doesn't matter आप किस library से use कर रहे हो, because everything has their different name place, right? हर मॉड्यूल में हो सकता है कि there are certain things which is different in seal function of math than NumPy. So it is your choice from which library you want to use these operations. As far as your job is getting done, it's completely fine. Okay, so you can use whatever you want to use it from. You can use log, exponential functions, so all these functions are available. You can use arithmetic functions, right, like addition, positive, negative, multiply, power, subtract. So all these functions are available. You can try them out. Okay, then square and all these things are there. Then what else? String operations. Okay. Then, as I was telling you, right, it is not about only integers or numbers. You can have string also, right? You can have a array of string as well. So what are different operations you can perform in this? Like you can do character lower and upper, right? So there is this function called np-char lower, wherein if you pass this, everything will be converted into a lowercase. Similarly, you have upper, where everything will be converted into uppercase, right? So that these functions are available. Then you have something called split also, wherein you can call np-char split, and you can give separator like how you want to split, right? By default it will be done using space, but let's say if you want to give some other separator, you can give that using this argument sep equal to, then your character, I mean your entire array will be splitted, or whatever you are giving this, right? So that will be splitted, right? So for example, let's try this out. You see it has converted into a array list, and it has created this. So let's see if I give this within this, how will it react? So yeah, I think it's same, right? Right, so let's say if I have this kind of thing, right, and I have a separator, it has created a list, right? And then where geeks for has is one element and this is another, so it is a list and it's a array of a list. Okay, so that's how it has created it, right? So these operations also you can perform. Okay, then you have join also. You can join these two elements. Like if you do this, so what it will do is whatever elements are there, right, by default character wise it will join. Okay, and here also it will join, for this one. So let's see how it will join over here in this case. So what it has done, because there are two lists, right, so it has joined this element using this and this word using this. So that's how it has joined. So likewise it can do join operations as well. Then you have other operations like strip. So strip, what it does is it will remove leading and trailing spaces. So for example, let's say let me np dot char dot strip, right? And let's say I have given some white spaces at the beginning, and it happens a lot. And let's say white spaces again, then white spaces again. So if you see, it has stripped the white spaces only at the trailing and the leading, because those are useless, right? White spaces in between are not useless. So it is a very important step whenever you are doing text pre-processing, because what happen is when you try to do a string match, na, it won't happen if you have some spaces. So for example, let's say I define a string and I say I am Neha, okay, and I created another string called B, and where I don't have these leading spaces, right? or trailing spaces, because that's so how come these trailing and leading spaces come? Because of some data conversion. Let's say you have got some data from document file or some Excel file, so you don't realize, but there is by default some spaces exist, so it will be there by default, but your job is to remove it, because if you see a equal to b, it will give you false, even though it is same for you, but it is not same for Python, because simply here space also have some meaning. For you it is not. For you it is not, it doesn't matter if there is a leading and trailing space, but for Python it does, and that's the reason you have to clean it. Okay, so that's why you can simply, what you do, if you do this np dot char dot strip of this a, now if you do, it is true. Okay, of course you have to maybe you have to give it like this, so that it, I mean, you have to they do a slicing, because here you are getting an array, but that's fine. The point is it has now true, it's not false. Okay, so always make sure you are doing some kind of this pre-processing steps. Okay, similarly आप capitalize कर सकते हो. Capitalize as in first character of each word will be a bold letter or a capital letter. Then you will have caps on of the small ones. Okay, likewise you have is a strip, you can check r strip, you can check, right? R strip for trailing characters removed. Okay, and then you have upper lower, so all these operations perform are there, you can use them. You can count also a substring. So for example, if you want to count how many a are there in geek, you can check it out, right? So this is the array, and you want to check how many geeks are there, so you can check wherever it is there, it has one, otherwise it's zero. So 4 it's zero, here again it is one. Similarly here, how many times fo has appeared, so zero, then again one and zero. So likewise it can do a count a substring also. Okay, then you can do r find. So whatever operations actually we saw, right? So these operations also it can be done over here. R find it can do, simply it will search in a string, right? So if it is finding, then it will give 0, else it will give -1. Okay, so it is finding geek over here, so that's why it has given 0. If it is not finding, then it will give -1. Okay, you can check if is numeric or not, right? So this thing you can do, find index, is alpha, is digit, so all these things you can test it out, right? So all these operations exist. You can do character equalness. So one thing I just now I did, right? I did like gave like this, so instead of this I could have checked np dot char equal. I could have given those two variable over here, and then I could have tested it out, right? So for example here I can check equal a comma b, it says false, right? I could have done that, right? Okay, then not equal also you can check unequal, right? You can check greater, that whether it is greater than this or not. So basically it will count just the length of the element, I believe. Okay, greater than equal length, so it will just count whether length of the letter characters is more in this or not. Okay, so these are some of the string operations which you can perform in NumPy. Okay, so let's do one thing. I think it's too much. So let's take some 5 minutes break. Yeah, I understand. So let's take some 5 minute, 10 minutes break. Okay, let's come back at 12:35 and then we'll resume. Okay. Okay. Cool. Okay, I hope everyone is back from break and I'm audible. Let me share my screen. Is my screen visible? Can somebody confirm? Okay, cool. Let's get going then. Yeah. So so we were going through this, right? So before that, I thought there is one thing which I think I have to make one thing clear, right? So far we have dealt with mostly 2D data frames, right? So what do I mean 2D data frames? So here, as you can see, let's say I created this A1. Let me, this is 2D. When I say A dot shape, so there are only two elements, right? 2 comma 3. So it is 2D, right? So if I print A, that's how it looks like, right? So we have number of rows 2 and number of rows columns are 3. So that's why you see there are 3 columns, 1, 2, 3 and 2 rows, correct? So that is what the 2D data frame look like or 2D array look like. Okay, now what is 3D? If I have 3 dimension instead of 2 dimension, so let's imagine how that 3 dimension would be. So what I did here, I simply added one more addition dimension, that is in that third dimension it is 2 length. Okay, so how will it look like? It will look like something like this. So you can think of like, you always start from the last, not from the beginning. So last, how it looks like, it has column 2, right? And then it has rows 3. So that's what you are seeing. This is your last element, like basic element, correct? So basic element is 3 number of rows and 2 number of columns. Now how many times this is getting repeated? 2 times, because it is 2 rows, correct? So it is 2 rows, which means that, what does it mean? Basically, this is my one basic element. Now it will repeat twice. So what does it mean? The same structure you will see here, okay, enclosed with two braces. So one brace is for one dimension. Okay, so this is one dimension, and so that's why you see that's one brace is closed here. This is two dimension, that's why this second brace closes here. Now the third dimension braces closes here. Okay, so that's where your braces closement happen, correct? So let me show you. Let me see, if it is 4, then how will it change? You see, simply रो का नंबर 3 था पहले, अब वो 4 हो गया. Let me show here. अगर ये यहाँ 3 होता, then what happens? ये entire block simply repeated one more time. You see, it has just got repeated one more time because now I have 3 length in first dimension. Clear? I will repeat again. So this is 3 dimension. This was 2 dimensions, it was simple. So what is 2 dimension? Always start from the last. So 3 number of columns, 2 number of rows. That is your basic unit. So 3 number of columns, 2 number of rows, that's your basic element. And because this is only 2D, that's why you see 2 brackets over here, right? First bracket closes here, that is one dimension. Then second bracket closes here. How many number of dimensions? That many number of braces you will see. These square brackets I'm talking about, right? At the last, of course, you will not be counting this because this is, you cannot count that here closing here, no. So it is just one element which is getting close here. Then again, this is second and this is third. So always count from the last, you will see 3 braces, or from the beginning. If it is 3, which means that it is 3 dimension. Okay, that's how you count how many number of dimensions are there. Or you can check the shape also. So shape may, if you see now of this, let me print B again. So if I do B dot shape, you will see 3,2, or you can check size also. Size is 24, it's actually multiplier of the two. Sizes tells you how many number of elements are there. So if you count, there will be 24. Simply 3 multiplied by 4, 12 multiplied by 2, 24. Okay. And how do I know? How do I read it? Simply you start from the last, 2 number of columns, 4 number of rows in basic element. So this is my basic element. Now it is getting repeated 3 times. Okay, so it's getting repeated 3 times. Simply, if it is 4 dimension, that's how it will look like. Again, start with last 4 number of columns, 2 number of rows. So this is your basic element, correct? Now after this, your second dimension closes. So that's where you see closement of your second dimension. Now again, it is repeating 3 times. So that's why you see 1, 2 and 3. Again, this is the end of your another dimension. So that's why you see one more bracket closes here. Now it is again first dimension is 2 times. So this entire thing is repeated now one more time, and that's where it is done. So you can see the placement of the last close. So this is 4 dimension. That's why you see 1, 2, 3, 4. So that's how you read or interpret the cells. Okay, so let me show you if I have to access these elements, how I can do. Let's say first element, if I want to close, I want to see this is this first element, you see, because first dimension is 2. So first is this entire thing, if I say 1, it will be again showing me this, and if I say 2, it won't, because there is no 2, there are only 2, right? Similarly, if I have to access in first dimension, then again in second dimension, let's say I want to just see first element, right? Or a second element, it will be this, because this is your second dimension, right? Then again within this you can plot that you want to see how many of there are 2, right? So you can see again 1, so you will be seeing only one row. Then again within this, let's say if you want to see columns, you will be seeing just one single value. 5 is not there, sorry, so it will only be 3. So you see only one value. So likewise you can reach out to which again indexing you can do, no matter if you have more higher than 2 dimension thing. So I hope this more than 2 dimension thing you are able to read and understand. Any confusion so far? No? Okay, good. So then let's continue whatever we were doing, right? So there are some more important operations in NumPy, which it does, right? Like sorting, searching, counting. Okay. So far what we are doing, we are learning one by one what all different operations exist. Then ultimately at the end, we will consolidate everything. Consolidate as in one problem we will try to solve, where we will be implementing all these operations. Okay. So I will walk you through one block where I will be consolidating all these operations, right? So then there is this sorting thing exists. So as the name suggests, right, it simply sort your data. So now how to sort it? Simply, let's say if you want to sort it along first axis. So let me show you this. Right. So if I print air1, so how it has sorted based on the first axis. So what is your first axis? It's this. So your actual array was this. Now it has sorted based on the your row wise, like I mean this axis wise. Okay, column wise it has sorted. So whatever is the lowest, it has put first, and then 10, 12. Likewise, it has done. Okay, so this is the first axis. And then let's say if you want to sort it with some other axis, you have -1 away option also. So let's say if I do -1, how it will put? It has simply put, I believe, row wise. So it has done row wise, like this it has done. So you see it has just changed over here because 1 was lesser than 10. So it has put 1 first. So likewise you can sort it out. And if you do none, I think by default it will simply sort. It will not put an array. It will simply sort, basically it has converted 2D array into 1D array, because it has considered all the element as a list and it has simply sorted it out. So if you want to make sure your structure remains same, your shape of the array is intact, you give either 0 or -1, or if you just want to sort it like this, then you can give none. Okay. So likewise, you do the sorting. Then you have argument sort as well. So this was simple sort, right? What this argument sort does is actually it tells you the index uh, of the array, okay, after sorting. So what does it mean? Let me show you this. If I do this, right, and then if I do this, can you see what it has done? So it has sorted, but it has, can so, acha, somebody want to take a guess? How can I get, so why I don't see 9 in this cell? Can somebody tell me? Want to take a guess? Somebody's answering. Nope. I'll show you again. So this was the array. I simply did a argument sort instead of simple sort. So it returned me this. Now this is, it has done the sorting, but instead of value returning, it has returned the index. And that's where argument sort is very important. Whenever you want to know which index value is bigger, that's where you use argument sort, not sort, because you are interested at which place you have maximum value. Because what happened most of the time, let's say, right, like I can give you a practical example. Let's say you have a data frame or you have an array of student mask, right? So you want to know that who is the person, who is the student who has got the maximum mask, at the third place. So who is the student who at the third place? Tell me this, right? So how will you get it? You will do the argument sort, okay, and then you will, that's how you will get the index, okay, that this person, it is coming at the third place, so I am interested in the index of it. Okay, so as you can see here, my maximum number is 9, and that is coming at the first place, right? So that's why you see 0 at the last, because that is 0 index. Similarly, 1 is the minimum number, and that index for this is 2, and that's why you see 2 is coming here. So this is nothing but index of index sorting order. Okay. So let's say if I'm interested in anything which is, number, I can get it by simply passing this index into A. So let's say if I'm interested in this, I can simply pass this in A. That's all. And I will get the value. The first value is 1, right? So likewise, the seventh value is, I will get, the 7 is not there. Sixth value is this, I will get 9. My last value is 9. So likewise, I can go. Okay. Sort is directly, it will return the value. Argument sort means it will return argument or index. Okay. So this is something which you can do. Then you have this, right? Sort complete. Then you have searching also. So what this searching to? Likewise, you have argument sort, right? Likewise, you have argument max also. So what it does is it will directly tell you what is the maximum value of it, right? So for example, if I do this, okay, this is the array. Sorry, NP, right? So I can do NP dot argument. So you can see there is sort, max, min also. So max, then we pass array, and if I do this, it will tell me 11. Again, it is telling me the index of the maximum value. So let's say again, if I, so this now it has tell in entire list or entire element. Let's say if I want to do row wise or column wise. So if it is row wise, it will tell me what is the maximum element. So row wise, if you see, it is third value, right? Actually, row wise and column wise, both it is third. So that's why you won't see the difference, because in here also now you are getting, no, sorry, you'll see the difference, right? So sorry, the row wise, if you see, right, it has given you third, that is in each row you have this last element as maximum, right? So you have three rows, so that's why you got three values, and that is at the fourth place or third place, right? Similarly, column wise, if you want to do, you can do it like this. So column wise, it is the this operation, like the second value, right? For all the columns, it is the maximum value. Likewise, you can do the arc min also. Okay, so it is very much similar to NP max or NP sort or NP min, just that wherever you see arc before that, you are returning the index, not the actual value. Okay, fine. If you do nan argmax, so I think it will ignore the nan values and still it will give you. So what happen is, if you perform this, right, and if you have nan values or na or null values in your thing, it will fail. It will give you error that any exists. So simply to avoid it, you can use a nan argmax. So it will avoid nan value and still it will give you the maximum value, right? Then you have argmin, does the same thing. Okay, so this is about all sorting and happening. Then another important operation of NumPy is random sampling, right? So what this random sampling does is, basically अभी तक हमने देखा कि let's say if you have any sequence or something, right? That from that you want to create some arrays. But what if you want to create some random arrays which need not to be in sequence, which can have any number given a range? Then how do you create it? Simply you can create array using this values. So how to do it? You can actually, in NumPy there is this function called random dot randit, which means that randomly it will generate numbers. Now between what numbers it will generate, let's say minimum value you gave 4 and maximum value you gave 30, and let's say size you gave 5, right? So if I do that, it has generated a array of values between 4 to 30 and length of 5. Okay, so likewise you can generate some random integers or number array also. So all these things are important whenever you are doing some testing and all, right? That time you need lot of random initialized array. That time this particular function is useful. You can give size here 5, 2 dimension, 3 dimension as well, right? So it will give you a 2D array. You can in fact get the 3D array also, like this, you see. So it is up to you how much dimension you want, what value and ranges you want, it will be doing it. So whatever low value you will give, that will be included. So you see 4, but this value will not be included. You will see the last value or maximum value is 29. You won't find 30 over here because this is open bracket. This is not included. So if you want to include 30, you have to give 31. Then now you will see 30. So you see 30. Earlier it was only 29. Okay, so all these numbers are randomly generated. So likewise, you can create randomly generated arrays also by this simple line. If it is a 2D, 3D, no matter what, you can simply create it like this. Okay, any questions so far? I hope not. Cool. So likewise, you have created one dimensional array. You can create two dimensional array, right? You can simply give 2 comma 3 and it will work. You can give any dimension, it will be created, right? Then what else is remaining? This is a randit function. Then you can do a random sample also. So random sample, which means that if you have, let's say you have defined one big array, then you can do the random sample of out of that array. Okay, so it's like one of the function doing random sampling. It returns an array of specified shape and fills it with random floats. Okay, so random int was actually for integers. Here you can get the float values as well. So here if you do directly random sample, you just give the size, you see you are getting the float values. So random int is for only integer values, and if you do random sample, it is for float values. Okay, so here you see all the float values you are getting. Everything is same here. Because it is float value, you don't have to give the range, because anyhow it will be within 0 to 1, right? So you don't have to give the range, just that you can just give the shape. Okay. uh, then what else you have? Then you have ranf. So this is also doing random sampling in NumPy. It returns an array of specified shape and fills it with random floats in half open interval. So again, it is, again, see, it is very much similar to random sample. So if you know how to use random sample, that's fine. You need not to know random as well, because there could be multiple ways to do one thing, right? Then you have random integers, which is again simple, similar to what we learned in random ran it, right? So this also, again, it is same. Okay. uh, then you have these universal functions. Let's see what are these universal functions. So most of them we have already learned, right? Sine, cos, trigonometric function which we can perform. So we already saw we can perform trigonometric operations, right? Then we have statistical functions. So we have seen that we can perform min, max, we can actually do median, mean, standard deviation, average. So let's quickly check of these functions once. So let me just simply copy paste this entire thing and show you guys. So as we saw, right? So this is a weight array which we created. Now we can simply get the minimum and max of this. So minimum and max we got, right? Min is 45, max is 73, right? And then we got the range also. This np.ptp is nothing but the range. So in this, what we have got, basically the difference of the two. So if you do the 73 minus 45, you will get this value. So range is nothing but difference of max minus min. So that is PTP. Then we got the percentile. So for percentile, let's say 70% of the student where it falls, right? So what it does is it basically sort your entire thing, and whatever is the 70th percent value is coming, right? It will give you that value. So that is 55. So what does it mean? 70% of the student have weight less or than or equal to 55. So that is what you can see from your population. Most of the population you have actually less than 55 only. Correct? Only one 158 and 73 is the one, two, only 2% who has more than 55, right? Then you can get mean also, np.mean, median, standard deviation. So you can get all these values using simply this. So if it is 1D array, you can get it like this. If it is 2D, you can simply give the axis and you will get row wise or column wise operation. So those things are still applicable. Okay, cool. So all these mathematical operations you can perform on this statistical operations. Then you have bitwise operations. So I'm ignoring. So yeah, I think that's all in NumPy. So before I switch to the tutorial or that one blog which we'll be going through, I'll just take 1 minute pause, and yes, we. So if you any of you have any question, so somebody asked when we will use a spider. So you can use it today only, right? So I'll show you how to use it. So all these functions, see, there is no functionality difference. It's just the file formatting difference. Okay. So let me show you one thing. But okay, I will come to that in 5 minutes. If you have any question, just first ask those, and then I will move on to this. And somebody has asked, LMS PPT available on site is covering till dictionary. I have already told that I have already shared all these things to with ExcelR team. I will again ask them to upload it if they have not done. Okay. And uh, Jace, so I'm not sure which practice file you guys are talking about, Priyanka. So is it the Python file which I show you? Are you asking for that? Yeah, so this also which should be uploaded on the portal. I have already shared, so I will check again with the team. Uh, then I'll confirm with you guys tomorrow. I will ask them they do it by today at any cost. Okay, fine. Any other question in NumPy library, whatever we have learned so far? Cool. ठीक है, तो सबसे पहले अपन स्पाइडर पे आते हैं, राइट? तो स्पाइडर आपको कैसे यूज करना है? तो लेट्स से आप मान लीजिए आपके पास यही नोटबुक है, ओके? आई क्रिएटेड दिस इन जुपिटर, आई वांट टू open this in spider. What I can do, simply you see this file option. I'm sharing my screen, right? You guys can see my screen. Yep, I think so. Okay, so in this, simply you see download as. So you can say download. There are multiple options. Either you can download as notebook, IPYNY is downloading as notebook, or you can download as Python, that is .py. So .py file is readable in spider. So you just download it as like this. You can keep this file, you might get some warning. So it is downloaded. Okay, now all you have to do is simply open spider. And how you can open spider? There are two ways. From anaconda navigator, if you have already, let me open that UI one more time. So it takes time, right? Because there are other thing also. But okay, let's say if it is open in your system, you can check there is something called spider written, right? And if it is not installed, so it will show you at the bottom whether you have to if it is not installed, it will tell you install, or if it is already installed, it will show you launch. So those options you will be getting. So like I show you, so this kind of screen will open, right? Now this is the spider symbol. Okay, this is what spider. Okay, and here if you see, so I don't know how to make, how do I make smaller these symbol? Okay, I'm unable to. Okay, but then this is the spider, right? So this is already installed in my system, and that's the reason here this button you see. If I just scroll a little bit down, you see it says launch, because I already have it installed. But in your system, you can check if it is not installed, it will be coming as install, because you see this is orange hai, it is not installed in my system, so it says install. So if just check if it is coming install or launch. Okay, so if it is coming as installed, you simply click on this, it will install for you, or else you can click on launch. Okay, so if it is already in, so likewise you can get, or if it is already installed in your system, then next time you don't have to open this, you can directly type spider and it will be coming here. You see it's in bracket, it shows anaconda 3 because I already installed via anaconda, that's why it is showing like this. So you can directly click from here also and open it. It is faster this way, because anaconda navigator opening it up, it takes a lot of time. Clear how to launch it or how to install it if it is not there? Okay, clear till this point? Fine. Then once you have open it, just this kind of screen will be opening it for you. For you it will be blank because you will guys will not have any py files, so it will be open, it will be like this. तो here you see this is where you can write your commands. जो भी आप अभी Python में लिखते आए हो, right, notebook में same commands you can type over here. So for example, import NumPy as n2. Okay, you can create your script over here and you can run them. To run it, you see this green say button, you can do the run file. So the entire file will be run with this, but that is fine. Let's say if you don't want to run the entire file, only one cell. So there is this F9 function. So if you do F9, I think this is F9 or what? Okay, so or you can do shift return, or you can do this double symbol. It says run current cell. So if you just do this, it will be just running this. Wait, I want to just run line, run file, run current cell. I don't want to run cell. I want to run the line current F9. You see, run selection or current line. This I symbol you see now, below this thing you have to run. So you see this line has run. So let's say if so whatever we used to do in Jupyter, na, shift enter or run, that's how you can run your thing line by line. And once your code is created, you can run your entire code by clicking on this, run entire cell or by this. Okay, that's how you can use the spider. And let's say if I want to import another py file or whatever just now I downloaded from this, right, you can simply do it, open file, and it is there in my downloads, right? So this file I downloaded today only just now, so I can open it over here. And now you see all the thing whatever I wrote over here, now it is there, it has come here. So it has come like this because I imported from the Jupyter. So it knows that it has created the line and all, right, but there is no problem, it will still run. So you see, you want to see, I can still select this and I can press this, it will run. So it has now defined the class. So now I can actually work here and say shark. If I want to create an object, I can create an object and do whatever I was doing in Jupyter now, I can do here. So it says that initial two requirements are missing. So I have to give those two variable name. Let's say n1, comma n2. You see it has created this. So it is say exactly same like हम जैसे Jupyter पे काम करते थे, the same way you can work over here. But now you yourself will see uh, working on Jupyter is much easier, because here every time you have to type here, and yeah, you know, again if you like it, then you copy paste here from here, because this will no longer be there, right? This is like a console, it will go away, it is just in memory, it will not get saved. Whatever you do, only thing will be saved here, this file, which you can save like this file and do the save as or save copy as, whatever you want to do. These are standard file operations. So why, simply that reason I like to work on Jupyter Notebook, and that is the reason why most of the industry guys work on that, and now I'm also get used to of it. And there is no point of, so you should be learning the advanced thing, right? Why do you guys want to learn the less advanced or less popular things, isn't it? So that's the whole point that I started with Jupyter Notebook. I'm not saying spider is not used, yes it is used. .py file are used if you have to run something in batch, right? If your output file is not useful, you have to do it. So I'm telling you the best practice, right? The best practice is you develop your code in Jupyter Notebook, and you simply import the file as py file, that's all. That's how easy it is. You import your py file, and it's done. You can use that for your running the batch command or something like that. And because these two things are convertible, you can save your ipy file into a py, and in fact from py file also you can load it like this. From here you can convert your py file into Jupyter Notebook file as well, and then you can open it in here. So these two formats are convertible, so there is no problem as such. Okay, any questions? I have already answered this. It depends on your use case. Mostly when you are developing the code, you work on Jupyter. Once it is developed and now you want to run it in a batch mode, that's where you simply convert it into a py file and use it. Okay. Configuration of my laptop, it's actually Windows 10 with uh, sorry, I'm not sure. Yeah, Windows 10 with actually I have higher RAM. I have 8 GB RAM. That's why it's much faster, and 64-bit operation processor. Okay. Any other question regarding Jupyter Spider? Okay, cool. So let's get back to the our NumPy library, right? So we have covered all the most useful functions which is there. So now let's take the use case of it, right? So now I will be taking you. So why I always teach you, most of the time you will see through blogs and all. If I want, I could have simply copy pasted this in PPT and walk you through the PPT and say that that's my content, but that's not the point, right? The point is, I want you guys to you know learn how to read blogs, because that's gonna be there with you. This session will end, I will be no longer be there for you guys, right? To uh, you know uh, to make things simpler for you. But what things will make simple for you is the blogs, because you will search for something, that how to do this, how to do this. Most of the times only blog is where you will find the answer, and that's the reason I always try to walk you through, guys, through some blogs, so that how to make your habit, to read these blogs, to make understand of these blogs faster, as comparative to other any other person who has never read blogs. Okay. And in fact, I myself like to read blogs even now. Okay, so that's the reason I read blog, and always find it easy to understand from blogs, right? So this blog I found very interesting one. Okay, so it is in NumPy tutorial. Okay, so your first step toward data science, right, in Python. So basically, if you here you can see whatever operations which will be taught in this blog now, those are the one which is most useful. You will see other operations like trigonometry functions and all that you won't find here because that's very rare which is used. Okay. So here they talk about what are the benefits, right? So actually NumPy is very fast library. So let's say if you there are certain operations called sum. Okay, so sum exists without NumPy also, so you can observe that there is a by default function called sum. So you see green, which means that this function already exists. So let's say if I do 1 2 3, it gave me 6. I can do, let's try that out now. Let me do one thing. Let me, so there, so one library I taught you, right? Time. Basically it tells you what is the time right now. So if I do this time dot time, which means that what is the time at this point, and then I will do the same thing after this step, and simply I will print en, sorry, en minus st, which means that it will tell me how much time does it took, but it just telling me in seconds. I want to be, it may tell you in milliseconds as well. So you see this, but when okay, maybe it is taking very much less time. Let me do one thing. Let me create a list, right? Uh, or let's do this now. I created one array over here, right? The C I created, right? So if I do sum of C, will it happen? Okay. So let me have this array which is such big, right? So this array, let me add, so that I have some okay, again it did not give some considerate number. I'm just thinking why it is. Okay. So actually, it is not giving in decimal. I mean, I'm just trying to understand why if I do np dot round and then decimals, let me give 5. Let give, yeah, okay, yeah. Let me do this then. Yes. Let's see if it is taking the same amount or not. Okay. So why it is taking just a second. Steven in1 in1 Steven natural rights. Okay. Okay. What I was trying to show you guys is a normal operation. If you do right, some whichever is there without NumPy library, it is slower as comparative to whatever you perform with NP sum. So somehow it was not giving up to the decimals, but maybe because it is very small operations I'm doing, right? But still you can see the marginal difference. So as you can see here, I did a sum of arrays without NumPy library. Okay, so then I am capturing what is the start time and what is the end time. Basically, when I do subtraction, how much time does this function took between these two lines, right? So it took this many seconds. Okay, and if I did the same thing with np.sum, how much time it took? It is taking n double nine, I mean 99730. So basically at this much order, still this is faster. So you can imagine it is such a simple operation, but typically we have lakhs of rows. Like my array is not that simple. My array might have 10,000 of rows, right, 100 of columns. So it can be such a big number, and that's where you see huge difference. So sometimes the difference is it is taking minutes. However, if you do the same thing with NumPy, it just takes fraction of seconds. So that's fast it is. So whenever, so I remember I was telling you that something might exist in few of more other library. So you have to take a call. Let's say if something is available by default in pandas and NumPy, you should always go for them, because those are meant to be faster as comparative to other libraries. Okay, so this is some kind of a thumb rule you can take. So numpys are faster, they have fewer loops, they have clear code, they have better quality, all these functions. So then they also talk about how to install, but you already know, so I'm just quickly skipping all these things over. So you can use in Python notebooks or Jupyter Lab, wherever you want. You can simply call them, define the arrays, right? So we already know all these things. So let's skip to what we don't know, right? So let's take first example where we will be learning few core concept. So here let's say I'm creating a array, a simple array I have created, and I'm simply running all these functions. So what does it mean? You can directly do the mean of the array, which we just now learned, right? You can get the mean of the array. You can actually subtract one value, the entire array, right? Then you can maybe add the two arrays, and simply you can just return the clip of that how does it look like, the new grades versus this, right? So you want to see that? Let's try to do this in Python, and let's see what all it gives you. So you have created the function, right? And in this function, if I simply pass this curve grades, I run this, so you see what happens, I got this return. So what is this return is, let me just run this again to get the new grades value. Because see, if I run now new grades, it won't give me anything. It will say it is not defined, because whatever is intermediate it is run now, it is a local. So remember we learned what is local variable, what is global variable. So all these are locally it is run. So outside this function they does not have any meaning. Whatever you return is only will be stored, other things won't be. That's why it won't be stored the internal value, and if I want to see what was there in new grades, I will have to run that again. So I can run this function again and see what is there in new grade. Okay, cool. So in this new grade, what this np clip does is, basically it is just in my grade, these are the value. Okay, and what this np clip does, okay, even I am not sure. Let's Google what this np clip does. Np dot clip, right, in Python. It used to clip or limit the values in array. Okay, so how you can use it? You can simply use, see the function as simple as this. So what it does is, let's say you have given an array. Now you have clip it. You give the array. You can give a min and max value of it. Okay, and you can simply clip it like this. Okay, cool. So you will be getting an array. How many size? 1, 2, 3, 4, 5, 6, 7, 8. So whatever is greater than 6, you have converted into 6, and whatever is less than 1, you have converted into 2, because minimum is 2. So that's how you have done the clipping. So here we are clipping this new grade, whatever we got here, right? With maximum value to be 100, right? So that's why you see maximum value to be 100. Whichever is greater than 100, you have converted into 100. Then and then you have got in the grade. Grades mean lower ke liye there is no clipping. Though that's why I think they have given the grades value over here. So for lower than 100, there is no problem. It is as it is, right? Wherever it is greater than 100, those has been converted to 100. So likewise, they have done the clipping. Okay, cool. Then so they have actually explained this nicely, that what all things we can do. Then there is something called shapes and axes. So this also we have learned, that how to check the shape of the array, how do we check the axis of the array, how we can do the swap axis, basically transpose, right? So that we can do. We also see how to do the reshape. So if you have an array, make sure the number of elements remain same, so you can swap them along. Understanding the axis, so we know for horizontal axis or for rows it is axis 1, and for column or vertical axis it is axis 0. So you can perform these operations row wise and column wise, right? Then you have broadcasting. So broadcasting is nothing but like this. So I have given you a list, and then you can broadcast into any shape what you want to. You just have to make sure whatever value you are giving, right, it has to be a so see, आपके पास जितना value है, those value only you can put, right? So number of elements will be 4 into this whatever is the size you can multiply, right? So basically you can check with the size also. So size of an array is equal to number of elements in that array, and that has to be there, right? That has to be equal to this. Similarly here, 6 into 8 is 48, and that's what it has to be there, right? So it has, you likewise you can broadcast your array, you can add those arrays. So all these operations we have already performed, right? Let's see what all different operations we have not performed. So see, let's focus more over here, data science operation. So what are the operations which we actually perform in when we are doing a data science or data analysis job, right? So here we do indexing. Okay, so indexing we have also learned, right? How I can access the array. So basically what I'm doing here is, I'm checking, I have put a loop for I between 0 to 3. right? And what I'm doing is here simply I'm accessing uh, all the elements for my rows for that particular column, correct? So this means all the rows, this means that particular column. So first I'm checking first column, that is 0, right? I start with 0. So first column is 16594, right? So if you add 16594, so let's see, right? Let's learn, let's run this and let's see what does it do. So it's run. Now let's see if I run this command, what happens. Okay, so nothing happens. Why? Actually, it should give me some true or false. Because this assert function, what it does, it checks. Let me show you 6, right? Yeah, now it will, okay. Because the values are 34, that's why it did not give anything. So basically what happened is, I think I already told you this assert function, right? It checks whether this your left hand side is equal to right hand side or not. If it is equal, then it does not do anything. Otherwise, it will give you error, assertion error. Okay. So if so this array, first of all, what we are checking here is row wise, I mean the column wise, sorry. So what this means is, so let me show you what this means. So if I put I equal to 0, it will be printing all the value of first column. You see 16594. So if I do sum of this, what it is, it will be 34. You see 34, right? Similarly, first column, I mean, this was first column, second column, right? I am iterating till 3, right? Second column, that is also 34. Third column, that is 2, that is also 34. So everything actually in this, it is 34. That's the reason it did not give any error, right? So likewise, you can do some testing also in your thing if you want to make sure whatever array you have generated, if some of that is equal to that. Similarly here you are doing it row wise, because you are selecting all the columns, and what you are doing for first row, right? So for first row and all the column, what you are doing is your first row, right? 16, 3, 2, 13. And if you do the sum, again it will be equal to 34. Correct? So that's what you were checking. And that's why you were not getting any problem, because there was no error. Correct? Now, as soon as you made it 35, it gave you assertion error. So you see here, if I make 33, you will start getting assertion error. And it will stop. You want to see at where it stops? It will stop at the first place only. Print I think it will give error because of simple reason. It was like this. I have to. You see, 0 only it stopped, because at first condition only it failed, and then after that it won't run. Clear? So these kind of operations you can perform. Uh, okay, then you can do masking and filtering. So what is masking and filtering? Simply, again, you have lens space. What it does, basically it creates some, let's see by ourselves, right? So what it does, so you see it has created starting from 5 ending till 50 with a space of 24. So with a sorry, not space of 24, length of this is 24. So if I save it, right, you will count the element or length of this, it will be 24. So basically, let's say if you don't want to create in a sequence, right, you want to generate some numbers within this range with a certain difference, right, that you can do. So likewise it has generated, and simply you can create that in array using this reshape command. So you can do that. If you do reshape -1, which means that it is just first thing. So let's say if I do this, right, it will automatically take care. You don't have to give anything as a -1, right? So basically it will be always by default it's 4 rows. So how am I, it is, so if there are 4 rows, what I will do, it will automatically divide 24 by 4, that is 6. So it knows that it has to create 6 columns. So that's why it has created 6 columns. -1 means when you don't want to do calculation, you just leave it. You either you give -1 or don't give anything, then also it will work, I think. Acha, no, it won't work. You have to give -1, sorry. So if you don't want to calculate anything, just give how many rows you want. It will automatically calculate how many columns. Okay, fine. So then you can do masking also like this, like whether true or false, right? You can give a condition and then simply this mask thing you will pass on and you will get all the values, right? We saw that how to put the condition and filter it out, right? So likewise, you can filter your thing. Okay. Then what else? What are the other important things we learned? So this also we already know, right? Uh, you can get those random values we learned, right? NumPy dot random integers, random float values. These things you can generate. Then we saw transposing and sorting as well, which you can do. So NP sort, NP argument sort we learned. Then yeah, this is one thing which we did not learn, that is concatenation, right? We saw how to join the two, right? So let me show you. uh, so this is a and b, right? If I add a and b, it will be adding element wise operation and it is doing, right? But this is not what I meant. I want to put these two arrays together. So basically we call it as concatenating or stacking. So that you can do. So there are two ways to do it, horizontal stack or vertical stack. So horizontal stack, how you can do, simply आपको horizontally add करना है. So let's say you can do np.h stack मतलब horizontal stack. So as you can see here, horizontally it has put it together, right? So if you do h stack मतलब कि 4861 ये एक मेरा मैट्रिक था, तो horizontally इसने इसके साइड में रख दिया. You see 3572. So horizontally you have placed it together. सिमिलरली यू कैन डू वर्टिकल स्टैक. वर्टिकल स्टैक में आप वर्टिकली रख रहे हो, यानी कि इसके नीचे रखा होता आपने. तो यू सी, जो भी पहले है वो पहले आएगा. बी आपने पहले रखा है तो पहले बी आएगा 3572 एंड इसके नीचे 4861 आ गया. ओके. So likewise you can do stacking of two arrays, horizontal stack, vertical stack, and we call it as concatenating also. Up to you, what do you want to do. हॉरिजॉन्टल वर्टिकल स्टैक में आपको एक्सेस नहीं देनी पड़ती है, बिकॉज इट इज क्लियर कि आपको हॉरिजॉन्टली रखना है या वर्टिकली रखना है. आपको अगर कॉन्कैटिनेट करना है तो दैट यू कैन डू. बाय डिफॉल्ट इट विल बी horizontal stack, I mean vertical stack. So let's say if I do like this, I will get a vertical stack, but I think if I give axis equal to 1, it will do a horizontal stack. So up to you. आप concatenate भी use कर सकते हो by giving access, or if you don't want to have any confusion, you just use horizontal stack and vertical stack. Both does the same thing. Any confusion in stacking or concatenation? No? Okay, perfect. Okay. Yeah. Then we have called aggregation. So I think I already told you, right? All these sum, max, min, standard deviation, all these operations you can perform. We call it aggregation operations. Okay. Yeah, that you can do. Then you can do this higher order function, also exponential and all these things. So that's also doable. These kind of operations you can perform, right? Uh, then what else? I think that's pretty much for the arrays, right? You can have special kind of arrays also from Excel file, right? So as I was telling you, so far we just saw if it everything is numerical or thing, right? But you can have something like this. Earlier I told you, right? So you can have these complicated arrays also, where your first letter is object, then you have two numbers followed by two numbers. So you can define it like this. So let me show you. But ideally we use it data frame अगर हमारे पास combination है types का, and that's the reason we have not put that much in focus, and tomorrow we are learning pandas data frame. So that time you will see we use data frame a lot when you have a mix of data types. Okay, because their operations are even better than NumPy for mixed data types. So as you can see here, I mean, it's not like you cannot create, you can, but preferable is pandas data frame. Okay, so likewise you can create that you have a name, right? Then you have a age and you have a power. You can say that what kind of thing it is. So in D type you are saying that name is a string, and I think here 10, which means that maximum letter could be 10. Then you are giving age, that is integer, power as an integer. So likewise you are defining an array. Then you can access of course with the index. First is this, second is this, name also you can just get it, value, power, like that you can get. Okay, so then there are more libraries. So I think that's all from the arrays, NumPy arrays. There was this another blog which I found. Again, I'm not walking you through. It's just to get you more clarity and more examples. So these are the two very good one. I will put it in a uh, content, and so that when you are going through the content, you will be able to see those links and you can go through them together. Okay. So with that, we have finished one library, that is NumPy. So what we learned, I'll just do a quick recap. We learned what are different operations in NumPy, very useful information, very powerful operations, how we can perform it, what are different kind of arrays, 1D array, 2D array, 3D arrays, right? Uh, uh, so we learned so many operations, and we will see them. So what will be happening is, right, as we are going through this library, and tomorrow we'll learn one more, then we'll, at the end we will be doing a EDA kind of a thing, where all these operations, we will be you solving a problem using all these operations. So that time you will get the use case of all these things. So today also you have got all the use cases, right? But you might be wondering, why do I need this, why do I need this, right? So these kind of problem will be solved. Okay. Yeah, so okay, one thing is, yes, it will be showing like this, but if you read it in your Jupyter notebook now, just try reading this file, it will be opening properly, even though it says .json file. But try loading this in your Python. How you can load it? Jupyter notebook. Sorry, don't open that in PyY file or Spider. Whenever you see these kind of things, right? Cells and all these things. This is IPYNY format, notebook format. So just open your Python session like this. You will see this browser, right? You can open, you can just upload it from here, or wherever your file is, you can just get access from there. Go to the folder wherever it is, let's say downloads mein hai, or wherever it is, you just go to this particular file and just launch it like this. It will be opening properly in your Jupyter notebook. Here यहाँ पर आप properly देख सकोगे अपनी file को. Because if I also show you this file in notepad ना, you will see the same thing. You wanna see? See, ये जो untitled file है, अगर मैं इसको notepad में खोलती हूँ या JSON format में खोलती हूँ, I will see the same thing what you have put it over here. See notepad. You see, ऐसे ही दिख रहा है ना आपको, ऐसे ही आ रहा है ना, cell type, code, execution number, because it has all this metadata information and all. अगर आप इसको Python में notebook में खोलोगे, it will open properly. Clear? Not able to download, this is something you have to check with ExcelR team. So Bharat, can you please help them out? why they are not able to download the files. Bharat, can you hear me? Okay, it's fine, guys. I will check with XLR team regarding all the issues you are facing, right? Accessing the content and all. So I'll make sure that they are helping you out. Okay. Anything else apart from this access issue? Uh, any queries? So one workaround is Priyanka. If you are not able to download it now, if you really want to work it now, you can simply copy paste and put it in a open a file, a Word file, not Word file, a Notepad file. Just put it over there and try to open that in Jupyter. It should work. If it is not working like that, you can try giving a forcefully syntax that extension IPY and try to open that. It should open. Okay, just a workaround. But yeah, I mean, you should be able to download. I'll tell those guys. Okay, if nothing else, then thank you so much for your time. Tomorrow will be starting a new library called Pandas. That is even more important, like equally important to NumPy, and we'll be doing more practice around it. So just start, just do the practice of all this, and we'll see if you guys have any more questions. We'll answer that. Otherwise, we'll start with a new library. Okay. Thank you so much, everyone. Have a great day ahead, and yeah, talk to you tomorrow.